Now that we've seen the theory, let's move on to practice with examples. If you'll allow me, I'm going to begin with examples that don't work at all, because I'd rather make those mistakes myself in front of you to show you what not to do, rather than you making them yourselves. So, I'm going to apply what I did in the previous video, literally. I'm going to create a recursive function and call it function bracket bracket. For a function to be recursive, it needs to call itself. There, that's it. I've created a self-calling function. I'm going to create a main calling function bracket bracket too. This program won't be doing much. Let's add return bracket 0 bracket. I'm going to compile this and you'll see it won't display much, but it'll do something fun. Sigfall, but why? If you paid attention during the first video, and had I remembered what I said 10 minutes ago, we'd remember that a function needs a stopping condition. Otherwise, we put in on the stack, it calls itself, and again, and times 6, and again, and again, and again, and at some point, it blows up in your face because we've exceeded the stack size. We mustn't do this. You'll be surprised how often we do it though. So now, I'm wondering, maybe I should add a stopping condition so that my function doesn't call itself endlessly. So, I don't know. Let's start by adding a variable. I'm used to this, so let's add a variable here, then initialize it to 0 to have a counter. Then let's make an experiment. If I is less than or equal to 5, then I'll call the function, else I'll return 0. Okay? And before calling if in bracket bracket, I'm going to increment my I, else it'll never increase. It'll remain at 0 and my thingy won't ever work. Let's be logical. I'm going to compile this thing. It should work, right? Morning. That's alright. Nope, actually it doesn't work. That's ridiculous, right? So, what could I have possibly have done wrong? That's right. Look at the function. Look closely. I go into my function, I declare an I say I is equal to 0, okay. I check whether I is less than or equal to 5. Well, we know it's 0, so I increment it and call function. So I go back into the function for another loop, and then, oh right, I declare a variable, set it to 0. Of course it doesn't work. Because remember, I put function on the stack, it's got its own context and variables. So it's got its I, that's worth 0, then it increases to 1, then I call back the function. So I add another function on the stack that's got its own context and its own variables. See where I'm going with this. So my second function also has its own I, which is set to 0, and it's worth I, and therefore it isn't worth 5. So I call it, and again, you get my drift. So how could we fix this? Remember the basics of C. The part's about passing parameters and return values. You know that there's a way to pass values between functions. So what could we do? We could not declare our I here, but instead pass it as a parameter. Here we could test it. Actually, I'm going to add a return 0 warning. Once is fun, twice it's rotten. Then I'll pass my present I to my newer calling of function. I'm going to call it with 0 in my main to start by 0. So I'm going to have function with 0, it's worth less than 5, so it will increase by 1. Then call function with its new value 1. Now I have a function with 1, still worth less than 5, so let's increment it. It now calls a function that's now worth 2, and that's the behavior I wanted. So to show you it works, let me first add a write of D for demo or display. Right here before calling my function. Let's compile. Here we go. Displays D 6 times. Why 6? Because I went from 0 to 5 included. So that's 6. As it displays D 6 times, it proves my function was called 6 times exactly. That's what I wanted. Let me show you one last example to illustrate the principles of stack calling. I'm just going to add another write function. A write of F for finished right after a call to function. So there are two options. Either it will display df 6 times, Either it will display something else. In your opinion, what will be displayed? Let's see. Personally, I don't know. I'll find out with you. What will be displayed? Well, 6 times D and 6 times F. Why do you think that is? The reason is very simple. At the beginning, I'm pushing my function on the stack, so it executes up to a point. There's a write D, then a call to function, so I did a write D. A second function goes over my function, which isn't finished yet. I add one on top. I execute till it displays D. I call function again. I display D. I call function, etc., etc. After a while, I stop calling function. I go back. I get back to my old function, which was called by fn function. So write F happens. So after displaying all D's, I'll now display F, then return. Display F and return. Display F and return, etc., etc. Till I reach the bottom of my pile calling function, then return to my main function and exit my program. There you go. That's an example of a recursive function that doesn't do much. But it works perfectly. It has a stop condition that works. It displays what we ask without problems. And if you look closely, you'll notice in the end, it looks like a loop. I've got instruction blocks and a counter. My instructions are repeated. Recursion and iteration are quite different. You can do many things with both. Some operations are easier with iteration, others much simpler with recursion. You'll learn with experience. There are 2 things to remember from this video about recursive functions. A recursive function is 1. A function that calls itself. 2. It has a stopping condition, especially if you don't want it to blow up in your face. And if you use counters, make sure to relay them between each function's instances, parameters, and return values. That's all for today, so good luck for today's exercises. You're going to need it. Till next time.